Welcome to SPA Identity and Access Control with OpenID Connect and IdentityServer 4. That's not my worst title. So my name is Scott Brady. I work at a company called Rock Solid Knowledge, and I'm the Identity and Access Control lead there. So we're Bristol-based as well, just outside Parkway. So my role is kind of all things IdentityServer. So we're the European consulting or commercial partners for IdentityServer. So I work with Dom and Brock, picking up any extra consultancy, doing full dev projects with our team there, and conference talks like this, commercial support. We also do some products for IdentityServer. So we do the official administration UI for it. We've just completed SAML2P support, so that's been what I've had to do for the past few months, which I'm really happy about. And we've also done a kind of like a turnkey solution, which is coming out shortly, called Identity Express. Contractually obliged to say we're also Umbraco Go partners and Xamarin authorized consulting partners. Personally, I'm also a Pluralsight author, so check me out on there because I get paid for that. Yeah. Okay. Agenda. We're going to start off with a OAuth 2 recap. Yeah, just to get everyone on the same level, and then kind of cover the OpenID Connect basics. I'm not going to spend too much time on the basics because I kind of want to cover the next big point about kind of the worries about using all this stuff with single-page applications running inside the browser. And then we'll move on to a demo. So I've gone for a pre-canned demo for this one because I was told it's 45 minutes to an hour, and yeah, let's not anger the demo gods too much. Just a warning: there's no GIFs in this presentation. Yeah, we're doing security now. You're not meant to have fun. Yeah. So yeah, why all this stuff? Why OAuth and OpenID Connect? So things change. Yeah, that's especially true in our industry for computer science software development. And it's something of a running joke when it comes to JavaScript frameworks. So we used to have things like XML, SAML tokens, WS star, SAML2P, kind of all running over SOAP. Yeah, these kind of technologies we used to go to. But someone came up with these annoying little things called mobile devices. JavaScript became viable. And we have things like microservices. So, these are off-site premises, off-premises devices outside of your intranet, and they sure as hell don't work with SOAP. So, for instance, some things like maybe even client-side applications actually and mobile devices, they had some early limitations with request size limits. Yeah. So SAML2P started to struggle very fast with those. So yeah, what we're going to be talking about today is all around newer technologies, so JSON, JSON Web Tokens, OAuth and OpenID Connect, and they're all going to be running over HTTP. So I'll skip through these actually. I converted these from Google Drive to PowerPoint and didn't work so well. I just want to clarify kind of like the three layers of kind of like this process we're going to be talking about today, just to make sure we're all on the same level of vocabulary. The first thing I just want to mention is kind of the first layer is the user store. So where all our identity data is stored. Had things like credentials in there, email addresses. But these are different to authentication. So authentication is the act of verifying who a user is. Yeah, so proving they are who they say they are. So user store would be something like ASP.NET Identity, yeah, or ASP.NET Membership for a few years back now. Whilst authentication would be kind of like the cookie middleware we see these days and IdentityServer. Next we have authorization. So that's the act of kind of figuring out what someone is allowed to do. So are you actually allowed to access this resource you're requesting? Yeah. So they're not necessarily all interlinked. Yeah, they could be all separate. You don't have to be authenticated for authorization. It helps. Yeah. So just to clarify those. So yeah, OAuth 2. OAuth 2 is a authorization protocol. Yeah, so it's the act of saying, right, you're allowed to access something on my behalf. So better phrased, it's a delegation protocol. Yeah. So I go up to someone, I join an application and say, right, you're allowed to send emails on my behalf. So emphasis on the send emails. Yeah, so it's scoped access. I'm only giving you permission to send emails. You can't read them, you can't delete them, you sure as hell can't change my password. Yeah, so it's been designed for HTTP APIs. So we're actually talking about the right technology. So we're not trying to fit an older specification like SAML on top of something it's not meant to do. I think SAML is still trying to get HTTP API stuff sorted out. And the nice thing about it is we get both user authentication and client authentication. I'm not going to talk about why we don't use things like cookies for APIs or maybe even API keys or credential sharing, mainly because I want to keep it focused today. So check out this site here, my article, The Wrong Ways to Protect an API, for reasoning around that. All right, let's flip to this, it's going to annoy me. So the OAuth Dance. There's 4 players in an OAuth request. You have the protected resource, so your API. You have the authorization server, who's going to be in charge of saying, yes, you're allowed to access this API, no, you're not. We have the client application, so let's say like an ASP.NET MVC application, yeah. And we have the resource owner, who's typically a user, yeah. So we call it the resource owner because even though this API might be inside our company, we hold the data, we run the infrastructure. If it's something like their mailbox, yeah, that's still the user's property. Yeah, that belongs to them. It's their right to delegate access and say people can do stuff to it. And especially true if we're talking spoilers. Actually, I'll stop there. So the first thing we want to do is basically the client application goes up to the user and says, can I do this on your behalf? Yeah, can I send an email on your behalf? So at this point, the user or the resource owner might have to authenticate with the authorization server, yeah, prove they are who they say they are, they're allowed to delegate this permission. If that checks out, we get back what's called an authorization grant. In the ideal scenario, we'll be talking about something physical, yeah, explicit, like an authorization code, like a little ticket basically, which says, which corresponds directly to that consent, yeah. So this basically means I can access the API on their behalf. What then happens is that the client application goes up to the authorization server and says, right, the user, the user gave their permission for me to do this. I have a little ticket here. Here are my credentials. So here's proof that I'm allowed to actually do what I'm asking as well. And if everything checks out, the client application gets back an access token. Client application then doesn't do anything with that. It just attaches it to a request to the protected resource, saying, look, I've got a token here. I want to send an email. The protected resource then does something with the access token, yeah? I'm being purposely vague. I'll get to it in a minute. It might verify it in some way. If it's structured data, it might verify it locally, yeah? If it's unstructured data, so like some sort of random string, it might look it up in a database, confirm it's real and what it's allowed to do. Or it might ask the authorization server if it's, what are the details of this token. And then if everything checks out, you get a response back. So the nice thing about this is user credentials are now separate to client credentials, yeah? Only the authorization server sees any of these credentials. Another nice thing is the API has no idea about the client applications, doesn't need to care. And we've pretty much decoupled everything. We've separated concerns. No one's looking at each other's credentials anymore. So that was kind of the ideal scenario where we had that physical explicit code. Let's look at the problems with OAuth. Yeah, it's kind of a bit of a troubled specification. Yeah, So what happens when OAuth, well, V1 is popular? Yeah, everyone wants to say with V2. So as a result, no one agreed on anything. Yeah. So it went through, I think, 27, 28 different drafts before it was finalized. People threw their toys out the pram during this time and stormed out. People went off and implemented certain drafts before it got ratified. And as a result, people got hacked. They also never actually said what the token type was or how to verify it. Yeah, they were purposely vague about it. It's just something is an access token. And as a result, people implemented their own tokens, their own way of verifying them, and they got hacked. And finally, OAuth isn't authentication. Yeah, so it's just authorization. So the act of delegating permission to do something on someone's behalf. There's no proof that the user actually verified their presence. Yeah, they verified credentials. There's no proof there's even a user there. It could just be a machine-to-machine kind of communication happening. So people tried putting their own layer of identity, kind of authentication, on top of OAuth, and people like Facebook, LinkedIn especially, they got hacked. Yeah, it's just one of those things. It wasn't as simple as they thought. So this is where OpenID Connect comes in. Yeah, so I think the spec says it's a simple layer of authentication on top of OAuth. Yeah, so OAuth is still compatible, it still fully works, but now we just add this extra layer on top, which allows us to do authentication as well. So it formalizes OAuth, yeah? We do actually say what token types there are now, yeah? So it's a JSON Web Token, and you put in standardized cryptography, so we use the Jose specs. And as a result, we get standardized validation. Yeah, so we can actually get a token and prove it's not been tampered with locally and using cryptography. The authorization server becomes an identity provider. Yeah, so it provides both access to some random HTTP API, but it also provides data about the authentication event and about the user himself or themselves. Sorry. So that's in the form of what's called an identity resource. Yeah. So it's kind of like a whole other API where we get permission to access things like their profile data. Yeah. So I want to know what their first name is, their last name, their gender, their date of birth. We could say email, so we want to know if they have what their email address is, whether it's verified. And also brought in the concept of an identity token. So I like to explain this as, it's a way of, it represents the authentication event, yeah? And we'll have a look at this in detail in a bit. Okay, and it's designed to be as simple as possible for the client application. Yeah, so the complexity is in the identity provider, not in your client application who's trying to consume it. So we're trying to make authentication and authorization as easy as possible for people. I mean, it's still a bit complicated because of the cryptography stuff, but if you're using a library, the right library, yeah, it'll do it for you. So this is just kind of like an overview of what OpenID Connect brings. We have the kind of the JSON Web Token kind of stuff here. We have the OAuth and some of the extra OAuth specifications. And interesting things like discovery documentation. Yeah, so we can programmatically integrate with the OpenID Connect provider. Session management is another interesting thing we'll look at in a bit. Yeah, I'll leave it there for a minute. So there's 3 endpoints with OpenID Connect. You have the authorization endpoint. So that's where we saw all the human interaction before in that diagram. So that's where we'll redirect the user off to the identity provider and say, right, you need to go authenticate, prove who you are, and give us permission to do this on your behalf. We then have the token endpoint, which is it's just an API, yeah? So it's all back-channel communication. This is where we swap that code for a token. And then finally, we have the user info endpoint. which is, again, another API. But here we can actually use that access token, which we use to talk to various APIs, so sending emails, accessing some sort of admin area. And we can now swap the access token for identity data. So like I was saying, the profile information, the email information. I'm talking fast today, sorry. So this is a JSON Web Token. Yeah? Happy? Yeah. There's actually 3 dots in there somewhere. One near the top there and another one further on. And these just signify 3 different parts of a JSON Web Token. You have the header, which describes itself, basically. It describes the token. You have the second part, which is the payload. So that includes all the information about the authentication event, maybe a bit of identity data, just to tease the application. And then the third bit is the actual signature. So it's been signed, yeah? So it's digitally verifiable. So the first 2 parts are just base64 encoded. And this is what they look like. So the header, sorry, as you're saying there, right, we use the RSA SHA-256 algorithm to sign the token. Here's the key ID, the KID, which we can link back to what public key to use to verify this. We say type of token is the JSON Web Token. And then the payload, we've got things like not before time, expiration, and that's epoch time, so seconds since January the 1st, 1970. Big thing here is the issuer. So who actually issued the token? Is it who we expected to issue the token? That's quite an important one. We've got the intended audience. Yeah. So who is this identity token actually meant to be issued to? So with the access token, the intended audience was the API, yeah? The protected resource it was going to unlock for you. In this case, the identity token is only for the client. Yeah. We have the nonce, which has nothing to do with the KID. I don't know why they chose that. It's bizarre. They're obviously not English. So that's kind of like a randomly generated value. So when you make a request for the token, at some point you'll state the nonce. Some people are still going. And this is basically repeated back to you in the token. So it's a way of verifying that the token that's been sent to you was in response to the token you made. Yeah? So someone's not just copying tokens from some other application or from some other request, feeding it into your application. So that way they might try and impersonate someone. Yeah? So that's called a cut and paste attack. Issued at, session ID, sub is an interesting one, subject. So that's the unique identifier for this user within this application. Yeah. It could be a unique identifier across all the applications for this issuer, or it could be one generated especially for this app. Yeah. But it will always be the same for that user. And then finally we have identity provider. So we've said there, basically it was the local identity provider. It's IdentityServer or your actual OpenID provider. That could say something like Google or Facebook. Yeah? So if you logged in using those authentication methods, using an account from some other provider, you might say that there. And we have the AMR, which is the authentication method reference. So how they authenticated. So password in this case. And there's a nice spec out there now of loads of biometric versions. Maybe you want to do some logic about that. Who knows? You might say to log into this app, you must have used your fingerprint. Don't want to say any more about that. Yeah, so these tokens are issued once. Yeah, you use them to figure out who the user was, make sure it's actually a valid token, it's a valid authentication event, you're happy with it. If I started putting authorization data in there, yeah, so things like they're allowed to send email addresses, they can, they're allowed to write a prescription for this person, they are an administrator, yeah. what happens when I do something accidentally, yeah? Or I give someone the wrong permissions? So well, the question is, how do I revoke it? Yeah. Now you've got a token, it's got an expiration, lasts for an hour. How do I revoke that? Yeah. The thing is, I can't. I have to wait for them to expire. Yeah. So don't put authorization data in here. Just think about the issue of what if you accidentally give someone admin rights? How are you going to get that away from them? You phone them up and say, sorry, I accidentally gave you admin rights. Can you please log out and log back in? It's not going to go down well. So this is purely authentication. Don't try and put authorization data in here. Okay, so 2 client types. Confidential client, which is what we just kind of talked about a minute ago, with the tokens can be done accessed via the back channel. The client can keep a secret, so they can actually authenticate. However, if I have a mobile application and I deploy it with the same secret across hundreds of devices, is that secret a secret anymore? No. Same with JavaScript, yeah. So if I try using a secret in JavaScript, someone just hit F12 and they can go see it. So it's not really a secret anymore. So yeah. Applications running inside the browser, so all their source code is in the browser, they're running their single page application. They just can't do client authentication. So this means, like you're saying, what's the point in the code then? Yeah, the code doesn't add any extra because we can't put a secret with it. So the token's still going to come via the browser. So why don't we just ask for the token straight away? Yeah. So yeah, big thing to remember, your tokens are exposed. Yeah, they can be seen in the browser. As a user, if I hit F12, I could probably find the token itself. So actually, it's not all doom and gloom there. The identity token is, as I said, it's fine going via the browser. It can't really be reused because as long as your client applications are verifying the identity tokens correctly, so they're checking the nonce is what they're expecting, they're checking the issuer and the audience are what they're expecting, yeah, so the audiences themselves. You can't really reuse it, yeah. Access tokens, though, can be. And we'll look at how we can kind of combat this kind of stuff in a bit. There's no specification for client-side applications like this, yeah. There is for native apps and pretty much everything else going other than a SPA. Yeah, so we've kind of got to piece this stuff together ourselves and try and, it's a little bit of a community effort to try and maybe come up with a spec soon. Yeah, okay. So this is what a request actually looks like when using a SPA. We've got to use what's called the implicit authentication flow. So as I was saying before, we can't explicitly verify ourselves. We can't prove that we're this application really. There's no authorization grant as a result. So we just ask for the token straight up. Give me the token. So as a result, there's no use of the token endpoint. There's no use of client secrets. We do everything via the authorization endpoint. And as a result, everything via the browser. So when we use OpenID Connect, we have to pre-register our client application. Yeah, so that's where the client ID at the top there comes from. So I've said to them, yep, I'm Mr. OAuth client, I'm Mr. Angular client. I have a record in your database, most probably. We say what we want in return. So this dictates what flow we're using. So before, when we looked at the ideal situation, we were just asking for code. Yeah, and we swapped the code then for an identity token and an access token. In this case, we've just said, yeah, just give me the identity token straight to me. Give me the token as well at the same time. We also say what scopes we want to access. So what permissions about not permissions. What do we want to access on the user's behalf? So OpenID is their subject claim. So give me their unique identifier. Profile and email we've covered before. And we might want to say API1 or like API1.read. So we want read access to API1. Yeah, and then we have the redirect URI. So this is where a little bit of client authentication, I guess, comes in. So this is basically, you're telling the OpenID Connect provider, this is where I want you to send the tokens to. Yeah, so this endpoint is pre-registered within the OpenID Connect provider. If it's the wrong endpoint, he'll just go, no, sorry, not sending those tokens. And again, we have the nonce, which we expect to be repeated back to us. As a result of this authorize request, the user is going to be redirected to the identity provider. They're going to possibly log in. They might be logged in already. And then via the browser, we get redirected back to our callback, our redirect URI. And we include the tokens in the hash fragment on that. So using the hash fragment is mainly, again, to minimize attack surfaces. Yeah. So with hash fragments, everything before the hash is sent to the server. Everything afterwards is kept within the browser. Yeah. So the user agent, the browser, is going to see the tokens. We can't really get around that. But we can stop these tokens from pinging around the internet quite so much. So the alternative would be query string, where that would be sent to a server possibly. And it could even be cached, depending on what policies you're using. So we're saying before, I'll describe this first. So we get the identity token, which is going to be the bigger one. We also get the access token if we ask for it, which can potentially be a lot smaller. We can use some sort of other access token scheme. It doesn't necessarily have to be a JSON Web Token, this one. We say what type the access token is, so it's bearer. We'll see that in action in a bit. And we also say when it expires, which is in seconds. So I've done an hour there for a reason, and that's typically what I'd recommend for a client-side application where the token is potentially has more potential to be stolen. Yeah, so giving out long-lived tokens is just asking for trouble in this case. They're going via the browser. I mean, if you haven't secured your client-side application properly, they could easily be stolen. The user could even just hit F12 and go take the token, which I guess is fair enough. Yeah, it's kind of, we're doing it on their behalf anyway, but at the same time, the token wasn't really intended for them. So going on from long-lived tokens, we can't use the concept of refresh tokens. Yeah. So with OAuth and OpenID Connect, you can ask for another type of token again called a refresh token. And you can just use this indefinitely with your secret just to swap the refresh token for a new access token, and possibly even a new refresh token at the same time. But it allows you to keep doing long-lived processing after the user has left the application. In this case, again, it can't keep a secret. Even if you did use a secret, it's easily discoverable. So if you gave this guy a refresh token and someone stole that, they've just got unlimited access to your application or your APIs. So there's a couple of defenses here I just want to talk about, and we will talk about the alternative to refresh tokens. There's a couple of defenses. So for one, if we ask for identity token and token at the same time, the identity token will be given another claim in the payload called the access token hash. And it's actually a hash of the access token that's meant to be sent with it at the same time. So it's a little defense against the cut and paste attack again, where someone might go, okay, I'll log in, but then I'll intercept the request and paste in a token I've stolen from another user. So I can get access to the client application and then start sending emails maybe on someone else's behalf, maliciously. So we can prove that, verify that the token that was sent to us was intended to be as part of this request. Now there is one part which hasn't really been solved yet, and that's bearer tokens just being stolen after the fact. So we can verify that the tokens being sent to us are the ones that are meant to be sent to us, they're legitimate, they're intended for us. But then if someone steals that token after the fact and starts using it, our API just goes, yeah, all right. Yeah, as far as it knows, it's a valid token. So there's some specs around this being written right now, which should hopefully start solving these kind of problems. But I mean, it remains to be seen whether this really affects our like SPAs, whether it's going to be mainly for client server-side apps again. But those kind of things are like proof of possession tokens, HTTP token binding. That's the kind of stuff we're starting to implement to combat this. Right, code, and we can actually see what we've been talking about in action and hopefully make it a bit clearer. So yeah, we're using IdentityServer 4. You know, I'm paid to do IdentityServer 4, so of course I'm going to use it. But the main thing about it is it's a certified provider. Yeah, so it's actually, the OpenID Connect guys have actually looked, tested this thing, and proven that it works to specification. Yeah, there's no hidden gotchas in there. And there's, unlike some paid-for providers, there's no provider specifics in there locking you in, so there's no tweaks to the spec in there. Also, the main reason I like it is that it's actually a framework. So everything is done programmatically. I can actually start extending the protocols. So I've actually, you know, for instance, you can add in WS Federation, SAML2P. You don't like the way secrets are hashed or stored or compared? Go ahead, change it. Don't like the way, you know, even redirect URIs are validated? Go and change it. Unfortunately, a lot of other competitors are mainly like XML kind of config driven or closed source. And for the SPA itself, we're going to use another library, this time from written by Brock Allen, called OIDC Client.js. Again, this is certified as a relying party, so it's certified that it verifies tokens correctly, can authenticate a user safely. There's a couple of others we could be using. So there's one for TypeScript and one for Angular. But I thought, you know, not everyone here is going to be using Angular, so let's use something a bit more vanilla. Vanilla JavaScript works with any of it. So, demo time. So, I've got a small IdentityServer instance running. That's logging, that's not interesting. So to get IdentityServer up and running, all you have to do is this kind of block here in the DI part of your ASP.NET Core application. So here we're just saying, initializing some in-memory stores. So here's all our identity scopes. Here's a list of API scopes. Yeah, so the API scopes be your custom APIs, like your mail server. I keep coming back to that one. Maybe your prescription service or some sort of ordering service. Whilst the identity resource scopes are more, well, they're identity, yeah? So my username, my email address, my gender. .NET Core 2 support is on its way, but it's in RC1, I think, but release candidate's a new beta, yeah? So, yeah. If you don't call it RC, no one tries it. So, yeah, so we got some in-memory test users as well. Alice and Bob, and we've just put in like a development signing certificate. So this is the private key we'll be using to digitally sign our tokens we send out. And then all you need to do in your actual pipeline is just say use IdentityServer. Yeah, so that's just going to intercept any routes that match the actual protocol requests. And then you just plug in MVC afterwards because we've got a little UI around it which actually performs user authentication. So just to be clear, when we go back to that layer stuff, IdentityServer is the authentication layer. Yeah, so it does, sorry, not even authentication, it's kind of, it's the protocol layer. Yeah. If you want, when you actually want to do the authentication, so verifying a user's credentials, that's all up to you. Angular, they're kind of like the usual way of implementing kind of access control is via auth guards. So we've just got in here a can activate auth guard. So basically this will trigger when someone tries accessing a certain page. And we just return true or false if they're actually allowed to do it or not. If they're logged in, we say true. Yeah, you can go into this protected page. If not, we call a start authentication method, which we'll look at now. So I've extracted this out as an auth service just to show, you're not tightly coupled into one library. So this is the first thing we need to do. We actually need to kind of build up the information about our IdentityServer installation. Yeah, so the authority URL, where IdentityServer is running. We then need to start building up kind of information required to do the request. So our client ID, where the redirect URI, where we want our tokens to be sent back to. The response type, so ID token and token. So that just translates to the implicit flow. What scopes we want. And then there's a couple of nice little helper methods within the OIDC client library. So we've got filter protocol claims. So I don't really care about not before times and stuff like this. When you extract user data, don't include that. Yeah, that's what I was saying. And I really don't want to see the nonce in my application. We then have load user info. So this will trigger as soon as it verifies all the tokens. It's quite happy with it. And call the user info endpoint for you. So it'll get all the claims that it's allowed to find out about the user. So as we saw earlier, in the identity token, we'll just have the subject. So we can actually call automatically call the user info endpoint and find out their email address as well. So this is then reflected within IdentityServer. So we've got the client ID. We actually say what grant types the client is allowed to access, or allowed to communicate via. So we say implicit. We say what scopes it's actually allowed to use. Yeah. So not all providers actually have that. I think that's quite a useful feature. You can scope down access per client that way. I'm not sure why they don't all have that. We actually know about the redirect URI. Because it's going to be SPA, we also need to understand it's possibly going to be a cross-domain request. Yeah, and I always recommend deploying IdentityServer on each of your clients on a separate subdomain. Else you have what I had the problem a client had last week, where they had about 20 apps on one domain, and then wondered why they were getting cookie request length issues. Mainly because they're all squatting on the same thing. Yeah. So yeah, we need to say our core's origin, so that IdentityServer will actually allow some browser-based application to call across to it. Again, they're quite strict. We actually have to say we allow access tokens via the browser for this application. So it's to stop people accidentally doing that functionality, yeah, and forcing people to be aware of the possible security implementation they're causing here. And then we have the access token lifetime I've included. So this, again, strictness, the redirect URI has to be exactly the same on both sides, yeah. It will throw an error if there's casing issues. Yeah, or if there's a slash on the end of one but not the other. It's being just purposely paranoid there. So in the auth service, in the constructor, I basically just call the GetUser method. And that just checks the storage that the OIDC client has been configured to use. So it has a look in there to see if there's any tokens, maybe some profile data. So is anyone actually around? So by default, it uses session storage for the reasons we said earlier about not writing personal information to disk. You can swap that out for local storage if you don't care. Or you can use something not web storage like indexed DB, which personally I only found out about today, but it's been designed to work with that as well. The user object mostly contains lots of information about the tokens. So what token type it is, the actual access token. It will store the identity token. But of what's used to us programmatically is things like profile. So it automatically extracts any claims it can about the user. So if we go into profile, we'll see like, oh, yep, here's a claim type with email, and we can actually access it like that. Maybe displaying it on the page just to make the user feel a bit more welcome. And we have expired as well, which is something we want to be aware of at all times. So if the access token is expired, we might want to proactively do something about it. And I've just got some helper methods there for get claims. Get authorization header, we'll take a look at in a bit. But here's where the magic happens. So the start authentication method, or sign in redirect even, sorry. So this is where we just tell OADC client is do your thing, yeah. So we've configured it with the client settings. So here's all the information about yourself you need to know to do a successful authentication request. And by calling this, it will automatically generate that URL, yeah, the authorize request we saw earlier, and redirect the user to the authorization server using that URL. And then when that response comes back, we somehow want to call this sign in redirect callback, which includes all the token verification, which for some reason is something you have to say. Some OpenID Connect libraries don't do token validation. The hard bit, yeah, where you got to handle cryptography. They don't bother. And we tried to give them flack about it, but yeah. So it'll do the validation. It will make sure the identity token and token are the ones you're expecting, that they match each other. Well, they have the same hash, the access token hash inside the identity token. It'll do it all for you. Yeah, so all that stuff I said about before is useless knowledge. Just do it for you. So we have our callback URL I've just done as a component, which just on initialization we call complete authentication, and we do that validation in there. Anything else worth saying about that? Yeah, so there is another option in this library actually for sign in Popup. Yeah, so if your UX guys hate users leaving your web page and get really paranoid about lost sales, you could just do a pop-up. Yeah, personally, I don't really have a strong opinion either way. I prefer redirects, but you're welcome to use pop-up. I think there's also a community addition to the library which has support for Cordova, but we can, if anyone's interested in that kind of using Cordova or Ionic, so JavaScript running on a native device, give me a chat afterwards because there's some extra knowledge you'll probably benefit from. Yeah, so let's see this in action. I'm also available for UI design. Okay. I'm going to do preserve log and zoom in on that. So I'm going to try and access the protected area. This just simply has my auth guard on the root. So this will kick in the fact that there's no user in the storage, and we need to go to IdentityServer to authenticate. Oh, it's really fast. So the first thing it does, it needs to know where to redirect them to. Yeah, we've told them the authority, which is localhost 5000, but we haven't told it where the authorization endpoint is, or the user info endpoint. So the first thing it does is goes to the disco doc, which looks like this. So this is on a well-known endpoint, so the same endpoint for every OpenID Connect provider, and it has the same set of values depending on what's supported. So in here we can see things like the authorization endpoint, so that's where we're going to redirect the user and put our request on. User info endpoint, session endpoints, which we'll talk about later. But then we can start building up more kind of knowledge about the OpenID Connect provider. We can see what scopes they support. Yeah, you don't have to put all your scopes in this. These are the publicly advertised ones. What claim types you support, flows, even client secret methods, how you actually send a client secret. And then various different, like Jose kind of the algorithms supported for doing your JSON Web Tokens. What's of use mainly here is the JSON Web Key URL. So this is the public keys we're going to be using to verify our tokens, verify the signatures. So it's not like the case with like SAML where you have to swap big metadata endpoints at first, maybe swap keys and all this sort of stuff. It's all done programmatically now. And as you saw earlier, here's the KID, and that's the ID, because you could have multiple signing keys. So some could have expirations. You leave your public key up there so it can keep verifying them for maybe a week or so, but you can allow people to start using the new key already. So you can allow old keys to slowly fade out that way instead of just cutting them off at the heels. Okay. That's a bit extreme. There you go. So what happened next is our middleware, our client library, automatically generated the authorize request. So we've got the client ID, the redirect URI, response types, scopes, state, and nonce. So state is very similar to the nonce. Again, it's a value you're going to be matching back. But it just gets, state is, instead of being in the token, it's just echoed back on the return. So at this point, IdentityServer goes, right, I validated the request. This is a valid request. I'm happy with this. They're asking for stuff they're allowed to do, but they're not authenticated. So this is custom to your application. So this is some quick start UI Dom and Brock supply. They're very clear. Don't use it in production, but be honest, it's not a bad jumping off point to go and figure out what you need to do. And the ending of it is you basically just need to issue a cookie. You need to issue a cookie using the authentication scheme IdentityServer uses. So I'm just going to log in, just using a password in here. So I'm going to be Alice today. Just a reminder, remember me does not remember credentials. It's possibly a bad name for it. It's more of a remember my account for X amount of time. So you're saying remember me for 30 days. Otherwise, it just issues a cookie which is valid for the session only. So when you close the browser, next time you come along, you're going to have to re-authenticate with IdentityServer. I did a test before. So I'll show you at the end if we have time. But what also happens there is that we actually get a screen displayed to the user saying, do you give this client application permission to access these scopes on your behalf? So it's a consent screen. And you have the choice to say, actually, no, I don't want to give this client application my email address. It's up to you if you you even display that page. If it's an internal application, you can get away with not doing it. But if you're federating with like third-party clients, you definitely want to make people aware that you're going to be sharing information with them. So if Just Eat integrated with, I can't think of a rival now, but if you started allowing people to sign in, use your accounts to access their client applications, you really have to say, you really have to make them know we're going to be sending your email address to these people. And then on the return, see if we can see the request. Well, there's no need, it's in the browser here. So as I said, in the hash fragment, we've hit that auth callback endpoint. We have the identity token, the access token, and the token type, and expires in, like I was saying. So we can see here then that the library has automatically called the JSON Web Key endpoint for us to go get the public key to verify the token. If everything checks out, it calls the user info endpoint by attaching the, where is it? So it attaches the access token to the authorization header. So this is how we communicate with APIs protected by OAuth. Use the authorization header preferably. So here we say what type of token it is. We say the bearer type. And then we actually bung the token in there. And the response to that is just JSON with a load of personal details. Okay. So now if I go on my protected area, we can now get in there and we can see some personal details. So this is what happened in the background. We use session storage and we just paste in the token. We paste in all that user object we looked at. So when it expires, some profile data, access token. To protect your API using OAuth, all you need is this middleware here called use IdentityServer authentication. And that basically says check for a bearer token being available. Yeah. Again, we say our authority. So this is going to be using that well-known endpoint to configure itself. We can say API name, which says the token must have an audience of API 1. So the token is intended for me, the protected resource. We can say what scopes it must have. It doesn't have to have all of these, just needs to have one of them. And it'll validate that it has at least one of those scopes. And we recommend using this one because it's got a couple of extra features that the Microsoft one doesn't have. So mainly that allowed scopes. We can also start using other token types of this as well. So yeah, kind of the concept of reference tokens. But anyway, I'm not going to demo it because we're running out of time. But the implicit flow relies on the user still being in front of the browser. Yeah, so it relies on them still being active. So in that case, when the access token expires, yeah, we can just send them off to IdentityServer. They can click yes, give them a new access token or re-authenticate, and we can carry on our merry way. The only problem with that is, what if they've just filled in a form which took over an hour to do? Yeah, and they hit submit, and we send them off to IdentityServer, send them back, and it's a nice blank form. Yeah, which is infuriating, right? So this is where refresh tokens would have been handy. Yeah, we could have automatically detected, 401, the access token's expired. Let's get a new one and then resubmit the data. So because we're in the same session, we can normally safely assume that IdentityServer, they're still authenticated with an IdentityServer. Yeah, so the IdentityServer session will be much longer lived than the access token. So what OpenID Connect allows you to do is set a value in the query, in the request called prompt. Yeah, and you can say prompt equals none. So if they're logged in, just give me tokens. Yeah, just send tokens right back. If they're not logged in or if there's an error, throw, don't bother. Yeah. So what we can actually do in behind is open up an iframe. Yeah, it doesn't need to be displayed. And this just pings off to IdentityServer, generating a whole new authorization request. Yeah. If the user's still logged in, new tokens get sent back, and we can consume them and update our tokens internally. If the user's not logged in, well, when they hit submit on that form anyway, they're going to have an error. Yeah, they'll actually have to have their user experience disrupted. But that's one way we can get around it, just by keep issuing whole authorization requests. So when you have a JavaScript application, like I was saying, there might not be a request for quite a long time. So they could happily just live in the JavaScript application, mooching around, looking at data, doing whatever your JavaScript app does. So I was going to demo that bit today, but I managed to find a weird bug with Angular and using this library around, I think, by the seams of it, around the way Angular handles iframes. So I think it's been sandboxed in some weird way, so I can't manage the response properly. But yeah, I mean, other than that, with plain JavaScript, that works lovely. And we can keep the session going and get single sign out. Yeah, that elusive other side of the coin. Yeah, I'll stop waffling on now. Next steps, check us out on IdentityServer.com. So that's the commercial side of it. Otherwise, if you want community-driven articles, I've got a few on IdentityServer, OAuth, and OpenID Connect in general on scottbrady91.com. Otherwise, here's our products. Got to plug them, right?
More questions? Yes.
Yeah.
That's all.
Yeah.